Hello, we are working on binomial probabilities and binomial experiments using the Casio fx-CG50. We have an example that says, during the 2021 to 2022 NBA season, Robert Williams III of the Boston Celtics had the highest field goal completion rate in the league. He scored with 72.6% of his shots. Suppose you choose a random sample of 80 shots made by Robert during the 2021 to 2022 season. Let x equal the number of shots that scored points. Would this be a binomial probability distribution, or can this be modeled by a binomial probability distribution? The answer is yes. We have independent attempts. These are independent, meaning that the first shot that he makes, or a first shot selected, does not have any bearing on whether or not he makes the second shot as well. We have a fixed number of trials. In this case, we are looking at a sample of 80, and the probability is the same for all shots. So the probability is 0.726, because 72.6% right now as a decimal is 0.726. Lastly, we only have two outcomes. Either he successfully completes the attempt or he does not. All right, so first thing we want to do is calculate the mean and standard deviation. The mean is the same thing as the expected value. So if we were to ask the question, out of 80 attempts, how many shots will we expect Robert to make? Well, that's exactly what we're trying to find. All we need to do is take the number of shots attempted, multiply it by the probability that he successfully completes the shot, and we have our answer. So in this case, we'll just find 72.6% of 80, so we'll do 80 times 0.726. And we get 58.08, or 58 shots made. We can also find the standard deviation using the formula, the square root of n times p times q. Well, we haven't talked about that yet, but if p equals 0.726, q is just the complement, 1 minus p. So 1 minus 0.726 is, let's see, 1 minus 0.726 is 0.274. So when we do this calculation, we'll end up having 80 times 0.726 times 0.274. To type this into the Casio calculator, we're going to use the square root symbol, which is above x squared. So hit shift and then x squared. And we just type all these values in. 80 times 0.726 times 0.274. And essentially this is 3.99, which is close enough to 4. All right, so that's how we can find the mean and standard deviation for a binomial experiment. Part C asks us to use our calculator to find the probability that Robert scored with 60 of these shots. This is looking for exactly 60. When we are trying to find exactly 60, we're going to use BPD. I'll show two different ways of finding this in the calculator. So if you're familiar with the Casio calculator, you know that you can change the different types of options that we're using by hitting menu. First way of doing this is to hit menu and go to number 2. From the statistics screen, we can go to distribution, choose binomial, and go to BPD using F1. Our x value is 60. We want to find the probability that he scores on 60 attempts. So x is 60. Out of 80 total attempts, and he has a 0.726 probability of scoring on any one attempt. And we'll get the answer is 0.0911. The second way of accessing the binomial PDF, or binomial probability density function, is to use the option 1, which is the regular calculator screen. From here, we can go to the OPTN option button. We can go to the stat screen by pressing F5, And then we can go to the distribution screen by pressing F3. And then we can go to the binomial probabilities with F5, and then choose BPD from here. So I cleaned up my screen just a little bit so we can see exactly what we're typing in here. So we need to follow a specific pattern for the Casio calculator. The first thing we need to type in binomial PD is the X value, then the number of trials, then the probability of success using this function. So we're going to type in 60, use the comma button, which is above delete, then 80, use the comma button, and then 0.726. So we have 60, 80, 0.726. We don't need to worry about closing the parentheses. And we'll get the same thing, 0.0911, 0.0911. All right, now for part D, it says find the probability that Robert scored with more than 50 of these shots. More than 50. These can be a little bit confusing, but if we visualize this with a table, it's going to help us. So we can find a probability distribution or a table for all of the possible outcomes on 80 shots by listing them all out, 0 or 1 or 2 or 3, all the way up to 80. I'm going to put in the important numbers here just so we can visualize it. 49, 50, 51, all the way up to 80. We can find the individual probabilities by using the binomial probability density function, or BPD, in the Casio calculator. But in this case, we want to know more than 50. That would mean 51, or 52, or 53, so on and so forth, all the way up to 80. So I'm going to highlight the table here from 51 to 80. Well, we know that in the Casio calculator, we can find the cumulative probability using the BCD. So if we're trying to find a range of values in the Casio calculator, we can use the BCD function. So from here, again, if we're on the main calculator screen, or the math matrix one, we can go to OPTN for options, choose F5 for stat, choose F3 for distributions, F5 for binomial, and then F2 for BCD. Now this is a little bit confusing, but if we're going to use the BCD feature, we need to put the lower value first, comma, the upper value second, comma, the number of trials third, and the probability of success fourth. So in this case, the lower amount would be 51, the upper amount would be 80, the trials would be 80, and the probability of success is 0.726. So we'll type those in now. 51, comma, 80, comma, 80, comma, 0.726. And we get our solution, which is 0.9685. The second way of accessing the binomial CDF is to use menu, option 2, bring up statistics, and it's just right on the screen here, F5 for distribution, F5 for binomial, and then F2 for BCD. Probably a little bit easier to use this one because it's going to ask you for these things in order. So 51 is the lower value, execute for, I keep forgetting that, 80 for the upper value, execute, number of trials is still 80, and 0.726 is still the probability, and we get the same outcome. Binomial CD, C is the cumulative density function, or the cumulative distribution, 0.9685, same values. All right, we have another example here, which says an online retailer observes that on average, 15% of visitors to their website make a purchase. If they have 1,000 visitors in a day, What is the probability that fewer than 100 visitors make a purchase? All right, so an important step here is to try and figure out what it is that we're actually trying to find. Well, first of all, do we have a binomial distribution? I think we do. We have only two options. Either they make a purchase or they don't. Whether or not one visitor makes a purchase or not does not affect anyone else, so it is independent. And we have a fixed number of trials. We have 1,000 visitors in a day. So I always like to write down what we're given. In this case, n is 1,000, p is 0.15, and x is fewer than 100. Fewer than 100. Well, that would be less than 100. Or we could write this as x is less than or equal to 99. Because fewer than 100 does not include 100. So it's got to be less than 100. All right, so I'm going to show how to do this from the stats feature or the stats option. Less than 99 would be a cumulative distribution, because we're going to look for a number of different outcomes. So we're going to use the BCD of x is less than or equal to 99. Well, we're going to hit F5 for distribution, and then press F5 again for binomial, and then in this case F2 for BCD. If it's not set to variable already, make sure you do that by pressing F2. The lower value would be 0. The upper value would be 99, and the number of trials is 1,000, with a probability of success of 0.15, because 15% of visitors make a purchase. Then press enter, and we get some scientific notation. Let's talk about what that is. Let me just resize that. Slide it over. All right, so this -6, well, negative means that we're going to need to move it to the left. The 6 means we need to move it 6 place values. So that's 3, 4, 5, 6. So we need to add 5 zeros, 4, 5. So 1, 2, 3, 4, 5, and then a 1. Essentially, the probability of 1,000 visitors in a day with less than 100 making a purchase is 0. It's not exactly 0, but it's essentially 0. All right, next example says a software company estimates that 20% of its customers will renew their subscription. If they have 50 customers, what is the probability that at least 10 will renew? All right, same thing, same idea. We need to figure out what does it mean to be at least 10. At least 10 would mean 10 or more. Since we're talking about a group of outcomes with the Casio calculator, that is going to mean that we're looking for a cumulative distribution or cumulative probabilities. So again, I like to write down what we have. We have a sample size of 50, so our number of trials will be 50. The probability that they renew their subscription is 0.2 or 20%, and our x values are greater than or equal to 10. 10 or more. At least 10 means 10 or more, so greater than or equal to 10. That means that our lower value would be 10 and our upper value would be 50. I'm just going to slide this over because I'm going to add a screenshot from the calculator once we get to it. All right. So press exit from the previous screen, and we can just jump right to it. Again, from the stats window, hit F5, F5, and then F2 to pull up the binomial CDF. So our lower value will be 0. Nope, sorry, our lower value will be 10. I said that. Our upper value will be 50. Our number of trials is 50, our sample size, our n value is 50, and the probability that any one customer renews their subscription is 0.2. And we get the probability that x is greater than or equal to 10 is 0.5563, because the 5 rounds the 2 up. All right, and one last example. It says a light bulb manufacturer claims that their light bulbs have a defect rate of 5%. If a box contains 20 bulbs, what is the probability that exactly 2 bulbs are defective? So this is a binomial probability again because we have only 2 outcomes. Either the light bulb is defective or not. We have a fixed number of trials. In this case, we have 20. And the probability of success, or the probability of a defect, is 5%. I'll show 2 different ways of calculating this, depending on how you define these things. So n is 20, p is 0.05. This is the probability of a defect. Oops. Meant to make that letter D. Probability of defect. And in this case, we want exactly 2. So we can press exit, exit. From the stats window, we can press F5 for distributions, pull up the binomial with F5 again, and we're looking for the exact value, so we're going to use BPD for F1. X value of 2. The number of trials is 20. The probability of success is 0.05. It's kind of strange to say that a success would be finding a defective light bulb. But either way, we'll get that the probability that X is 2 is 0.1887. Again, rounding to 4 place values. So a second way that we could look at this is to say that the probability of success would be to get a non-defective light bulb, or a good light bulb. Which, if they have a defect rate of 5%, that means that they have, 95% of them are good or non-defective. And in that case, we would want 18 to be good or non-defective. And I'll show that this is going to end up giving us the same outcome. So if we make X value of 18, number of trials is still 20. Oops. But we change the probability to 0.95. We'll get the same exact outcome, right? That 0.1887. So it doesn't matter if you use the 95% good rate or the 5% defect rate, we'll get the same outcome. All right, so quick recap. If we are looking for the probability of exactly X outcomes, we will use the BPD option in the Casio calculator. If we are looking for the probability of a range of outcomes, so between a lower and an upper value, we will use the cumulative option BCD. Thanks for watching.